Hello and welcome to part 23 of the series on how to create a chess game with ReactJS. In this episode, we are going to extend the possible moves for the rest of the pieces. If you'd like to learn how to do this yourself, follow along. Last time we left off at the referee, which is right here. We have the method getPossiblePawnMoves, which makes a switch statement for the piece type and then, depending on the piece type, returns the possible moves. We have already created the possible moves for the pawn. We're going to name this with a small g, and then inside of our pawn rules, we are also going to name it with a small g, like so. The next thing that we are going to do is we are going to refactor the code which we have inside of the if statements right here to separate variables. What we have right now are all the moves that the pawn can do, which is a normal move. This is moving one tile up. A special move, which is moving two tiles up. The pawn can do that only once. And then we have the upper left attack and the upper right attack. All those variables are positions, which is why they are positions. And now instead of checking if the tile is occupied at this position, we can remove this position from here. So let's just go ahead and erase this. And we're going to say normal move right here. And we can put this after the normal move. We want to do the same for the special move. So a prerequisite is that the position.y is in a special row. And if it is in a special row, well, then we want to check if the special the position where the pawn is moving to is also free. So we say special move right here. So instead of defining the positions inside of the if statements, we define them here, and we also give a name to it, so we can use it right here, and it just makes it a little bit more readable, I think. We also want to replace this with the move that we have created. So this will be the normal move. And inside of here, we also want to replace this with a special move. Like so. Let's save this up. And as we see, we still have a compiler error. This is because in our referee, we made this with a small g and in the pawn rules as well. But up here, we still import it with a big G. So let's make that a small g and it should compile again. Well, let's also check if the positions are still correct. So if we pick up the pawn, we see that we can move two in front and now only one in front. So that's also still working. Next, we want to write the logic for checking if the pawn can attack. So say if we have a pawn right here, we can attack the pawn right here, and this pawn can attack the pawn right here, but we don't see a dot because it is not yet added to the possible moves. For the upper left attack, we say if tile is occupied by opponent, and then we say upper left attack, and we pass in the board state, and then the team type of the pawn, like so. If that tile is occupied, then we want to push that as a possible move. So we say possible moves that push, and then the upper left attack, like so. Next, we have the upper right attack. So we say tile is occupied by opponent. Upper right attack, the board state, and then the team of our pawn. And then inside of here we say possible moves that push, upper right attack, like so. So if we refresh the page, we didn't even have to refresh, I think, but it's fine. And we move the pawn. We see that we do get two dots, one in front of it and one in the upper right, because the other pawn is right there. Also what we see is that there is a little bug because, well, the enemy pawn is moving downwards and the circle is not in the middle of the tile. It probably has to do something with there are two CSS elements or something in that same position, I think. Yeah. probably, but it's fine for now. We can always make it more beautiful later on. Now that we have the normal attacks, we want to do the same for the ampersand move. So, well, we all know what it is now. If we move the pawn right here, then we have the possibility to hit right here. So if we go to this position, that pawn will go away. But we don't see a dot yet, so we are going to add that as well. We are going to add 2 more variables. The first one will be const left move, or left position, which is a position, and this position will be the pawn position.x -1, and then we have the pawn position.y, and then we also have a right position, which is the opposite of the left position. So we have pawn.position.x +1, and y will be pawn.position.y, like so. Now we have 2 positions for the left and right position. So if we have a pawn right here and we have an enemy pawn right here, this will be the right position, and we need the right position to check if there is an enemy at that location which has made a special move, which means that it has moved 2 tiles, and it is a pawn. That's important. So right here, we want to say, okay, if the tile where we are going to attack is not occupied by an opponent, tile is not occupied, so is occupied, like so, and then with a bang in front of it means, well, negative. So if the tile is not occupied, and then we want to say the upper left attack, we also need to pass an import state, like so. So, all right, there was no opponent in the upper left tile. If there is nothing at the upper left tile, then we want to do something. So, for example, say if there is an allied piece in that position. Let's see, can we get an allied piece right there? Yeah. So if there is an allied piece, it's not empty, but it's also not occupied by an opponent, so we won't go in either if statement. So right here, we have an empty tile, and then we want to check if the left position is being occupied by an opponent, and if that opponent has made an ampersand setup or ampersand kind of move. We say const left piece, which is of type piece, is equal to port state that find, and then we want to find the piece that has the same position as the left position. So we say p dot position and then left position. So this will be undefined, or it will be piece. And if it is a piece, then we want to do some checks, which will be if left piece is not equal to null, and left piece is a pawn, so piece type is equal to pawn. Let's see, piece type dot pawn, I think. Piece type dot pawn, yes. And if that piece type has the ampersand setup, then we say left piece dot ampersand. Then we want to add the possible move to our list. So possible moves dot push, and then still the upper left attack, like so. All right, so let's check this out on the board. If you move to here, move this one here, we can only move up front, but if you move the left one here, we can also move to the left. Great. If we see right here, we also have the same situation, but we cannot move to the left, and this one neither, because the ampersand setup is gone. It can only happen if the previous turn was, if the piece that we want to hit has made the double tile jump in the previous turn. All right. So now that we have this for the left one, we might also want to remove this, because only the pawn can make ampersand moves. So let's make this a little bit shorter by omitting that. We want to do the same for the right tag. So else if, and then tile is not occupied. Oh, tile is occupied. Upper right, and then the board state. Then we say const right piece is equal to, and we are going to copy over this for now, like so, and then we're going to put that right here. But instead of the left position, we're going to say right piece, right position, and then beneath here we say if right piece is not equal to null, and right piece dot ampersand, then we want to add it to the possible moves. Not pop, push, and then the upper right tag, like so. Let's save this up. We can remove this enter right here, and if we refresh the page, we move the pawn right here. We see that we can move to here now, and also to here. Next up, we are going to do the knight. So right here in our referee, we are going to make another case. Case piece type dot knight, and then return get possible knight moves, and we pass in the piece and the board state. Up here we import the get possible knight moves already, like so, and we also want to create the get possible knight moves. So we say export const get possible knight moves, this one is equal to, and then we want to pass in the knight, which is a piece, and then the board state, which is a piece array, and this will return an array of piece positions, so position array, and then we say const positions, or possible moves, I think we named it. And then we want to return the possible moves, like so. So let's check if this is the same as we did with the pawn. If we open that up, we also named it possible moves. Great. All right. So here we have the possible knight moves. We can reuse part of the logic that we have for the knight moves. So for now, we are going to copy over this whole piece of code, but don't worry, we are going to remove a lot as well. So right here, we don't need this, I think, and this neither. So we left with 2 for loops, which is all fine, because right now we want to write the logic for returning the possible moves. First, we're going to create a position for the vertical axis. So we say vertical move is equal, is a position which is equal to x of knight dot position dot x plus j, comma, and then y will be knight dot position dot y plus I times 2, like so. And then we also have one for the horizontal move. So we say horizontal move, which is of position, is equal to x, which is knight the position dot x plus I times 2, and then the y will be knight dot position dot y plus j, like so. And let's see, we need to put a column right here. So now we have 2 moves, and if we scroll up, we see that we have here the top and bottom side movement, which is y is equal to 2 times I and x is equal to j. If we go to here for the vertical move, we see that y is equal to 2 times I and x is equal to j. And the same goes for the horizontal move. In essence, we are reusing this logic, but we are writing it a little bit different. And also we are assigning it to some variables right now, instead of putting it inside of the if statements, like so. All right, so now that we have the vertical and the horizontal move, we want to check if that position has an opponent on it or it is empty. So if tile is empty or occupied by opponent, vertical move, and we pass in the board state, and the knight.team. Then we say possible moves dot push vertical move. And we want to do exactly the same for the horizontal move. So for now, if we save this up and refresh the page, we pick up the knight. We see that the vertical moves are all calculated, as in we see the bottom and the top, but the left and the right not. If we add it right here, so we say horizontal move. Quick tip, if you press Ctrl D on Windows, you can select the next occurrence. So right now I'm typing in both occurrences. Anyways, we also added the horizontal move right now, and we see that we have the dots on the horizontal axis as well. Alright, so next up we have the bishop. So I'm just going to copy over this function right here, and instead of our bishop rules, we're going to put this, and we want to close it off as well. We also want to make an array for the possible moves, which is a position array. It's empty, and then we want to return the possible moves. We want to rename this to bishop moves, and we want to use this in the referee. So right here we say case piece type dot bishop, return get possible bishop moves board state, like so. This will be an error because probably we don't import it yet, which is fine. We do now. All right, error fixed. So if we go inside of here, we want to probably copy over this as well. We can copy over the for loop right here and paste it right here. And for now we are going to remove everything inside of the for loop, and we are going to write a comment above here for the upper right movement. So let's save this up, try and refresh the page, and if we get a bishop out, so let's open up the bishop right here, we don't see any moves. What we are going to do is we are going to look if we can get the possible moves for the upper right movement. So for now we are going to say, okay, we are starting at our piece location, and then we are gradually going to the upper right each step we take in the for loop. We're going to create a variable named const destination. This is a position which will be equal to x, which is a bishop. I see that we still have the knight right here. Bishop.x, and then plus I, and actually it's bishop.position.x, and then we do the same for the y-axis. So y is equal to bishop.position.y plus I, like so. Now we have the destination, and what we want to do is we want to check, okay, if tile is occupied. No, that's not true. What we want to check is if the tile is empty, we can move there, or if the tile is occupied by an opponent, we can move there, but then we cannot move further. So let's first of all check if tile is occupied. Possible moves dot push destination, right? Because if it is not occupied, we can just move there. And also, by the way, I totally forgot to put the position right here. So destination and board state, like so. If we save this up and we pick up this bishop, we don't see any possible moves. We do see any possible moves, great. But what if we put an opponent right here? We see that we are moving over it and that we cannot move onto the opponent tile. So if the tile is not empty, we want to check if the tile is occupied by an opponent. So we say destination, board state, and bishop.team. If it is occupied by an opponent, we still want to push it as a possible move, but we don't want to look any further. So we say break. Now if we refresh the page and we get the bishop out again, so let's put it right here. And we put a pawn right here. We see that we can move until the opponent pawn, but not further. which is totally correct because we can take it, but we cannot move any further. A small bug is that we can move over our own pieces, so we also have to check else. If the tile is not empty and is not occupied by an opponent, that should mean that it is occupied by us. We also want to break. So if we save this up, we see that we can still move, and now we cannot move over the pawn anymore. Can we still do the normal things? Yes, we can. Great. So now we have the upper right movement. Next we want to do the same for the bottom right, bottom left and top left corners. The only thing changing, by the way, is the I value gets subtracted depending on which direction we are. We have all the directions. If we save this up and we take this bishop, we see that we can move in all directions. Next, we are going to create the possible moves for the rook. So we are going to copy over this for now and put it inside of the rook file right here. What we also are going to do is take this piece of code, put it right here, and then return the possible moves. We want to rename this to rook and rename this to get possible rook moves. And then to finish it off, we want to return our, we say case piece type dot rook, return get possible rook moves, and then we pass in the piece and the board state, like so. Also included as an import. Next, we want to copy over some of the logic from the bishop. So right here, we want to copy over the for loop, and we want to replace bishop with rook. And instead of saying that the destination is equal to, let's see, x plus y and y plus I, we want to say that it is equal to only x and y minus I. So right here we are checking for the top movement. Then we want to apply the same rules as we did with the bishop. So we're going to put this code right here, because if the destination is not occupied, we can move there. If the destination is occupied by an opponent, we can also move there, because we can take the opponent. And finally, if the position is not empty and it is not occupied by an opponent, we want to break out of the loop, because we cannot move any further. We also want to import this. So we say import, and then if we save this up, we should already see the vertical, and then I mean the top movement for the rook. So if we take the rook right here, we see that we have the bottom movement, which is fine. If we make this plus, it should be the top movement. So let's give it a second to re-render, and we see that it is now on the top side. Great. What we next are going to do is we are going to say, okay, bottom movement, and we are going to write this with a minus. If we save this up, we see that we have the top and bottom movement. We are going to do the same for the horizontal movement. The left and the right movement has been added as well, and if we pick up our rook, we can see that we can move in all directions. The next piece we are going to do will be the queen. We're going to grab this piece of code right here, and inside of the queen rules, we are going to add it inside of here. Rename this to queen, and also return the possible moves. And we are going to put this inside of our referee. So if the piece type is queen, then we want to return the get possible queen moves, like so, and also import it. As you know, the queen can move and diagonally, and horizontally. It also hits the same way as the rook and the bishop, meaning that it can move on top of an enemy unit, but not on top of your own units. So for the queen moves, all we need to do is we need to get the possible rook moves and also get the possible bishop moves. So what we are going to do for now, but is not the best solution, but we'll go with it for now, is we're going to copy over the logic for the rook moves, like so, and then also the logic for the bishop moves. So we're going to copy over this right here as well. This is basically the logic that we need for the queen movement. So we are going to replace all the rook words with queen. So right here we're going to say queen, and the way to select multiple occurrences is by pressing Ctrl D. We also want to do the same for the bishop. We want to rename this to queen as well. Let's save this up and refresh the page. If we pick up the queen, we see that we can move to a lot of places. And if we move to here, we see that we can also move to a lot of places. Alright, so we cannot move on this pawn. We cannot move through this pawn. We can move onto this tile. We can move onto that tile. So as you can see, it works. We are going to refactor this into its own function, or you can do that yourself if you'd like, so that the code isn't duplicated, because right now we have exactly the same code in the queen and in the rook and the bishop. For now we are going to keep going straight ahead with this, and we want to extend on it with the king rules. So if we open up the king rules, we're going to copy over this and put it right here. We want to return the possible moves and rename this to king. And this will be king as well. In the referee, we want to make a case for the king. So we say case piece type dot king, return get possible king moves. We don't need to import it because I just use autocomplete and that will take care of importing it. If we look up, we see that the get possible king moves is imported automatically. For the king moves, we do need the same logic as for the queen rules, with the only difference being that the king can only move one tile. So once again, we're going to copy over this whole piece of code. We're going to put it inside of the king rules right here. And everywhere where we have an 8, we want to write a 2. So let's see. With Ctrl D, we select all the 8s and then we replace them with 2s. We want to get the tile is occupied by opponent method or function, and we want to replace all the queens with kings. Not kings, with king. Right. Let's save this up, and if we take the king, we can see where we can move to, which is great. For now, we also can move into check and also out of check. Out of check is good, but into check, this is something we will fix in a future episode. I want to thank you for watching. I hope you could follow along. Leave a like down below, comment, subscribe, and I'll see you in the next episode. Bye!